Welcome to The Explainer. Today, we're going to get our hands dirty and talk about building something really cool, an advanced memory system for large language models. We're going to walk through a complete guide for building a server that basically gives your LLM a limitless memory, completely changing how it deals with huge amounts of information.
So, let's kick things off with a pretty big question, right? Why is it that even the most powerful LLMs, the ones that feel like magic, still struggle when you give them a long conversation or a massive document to read? This isn't some minor quirk. It's a huge bottleneck for any kind of complex, long-running task.
And this chart right here, from some amazing research out of MIT, really paints a picture. Look at that. Performance just tanks as the context gets longer. They have a great name for this, context rot. And it really proves that just throwing more memory at the problem, making the window bigger, it doesn't actually solve the underlying issue.
So here's what we're going to cover today. We'll start with the problem itself, then look at the really clever solution, these recursive models, and then we'll get into the good stuff, a step-by-step guide to actually building this thing, from the blueprint to the architecture, and finally to kicking off development.
Okay, let's dive into part one. We need to really understand what we're up against with this whole context rot thing. What is it, really? You see, the core issue here with context rot is that the model basically gets lost. It's like trying to find one specific sentence in a 1,000-page book without an index. The more information you give it, the more noise it has to sift through, and its ability to find that needle in the haystack just degrades. And this happens way before it even hits its technical token limit. So it's a quality problem, not just a quantity one. All right, so how do we fix this? Well, this brings us to a really brilliant breakthrough from the researchers at MIT's CSAIL. They came up with a whole new way of thinking about LLM memory, and they call it recursive language models, or RLMs for short.
And this quote right here, this is the light bulb moment. The key insight is to stop trying to stuff everything into the model's brain at once. Instead, you treat the long document, the massive prompt, as an environment that the model can explore. It's a total game changer.
This diagram shows you exactly how that works. See, the language model at the top, it doesn't actually see the whole massive prompt. Instead, it gets access to a code environment. And from there, it can write its own little Python scripts to poke around, break the problem down, and here's the really magical part, it can call itself to work on smaller, bite-sized pieces of the problem.
So, what you get is this really elegant 6-step process. It's like turning a giant, messy pile of information into a structured plan. You load the context into that code environment, and then the LLM puts on its developer hat. It starts writing code to inspect things, figure out a plan, and then it makes these recursive calls to itself to handle the smaller tasks. Then, it just collects all the answers and puts them together for the final response. It's not just reading text anymore. It's actually reasoning with code.
And the results, they speak for themselves. We're talking about a 79% accuracy improvement on really tough tasks, the kind of stuff where the model has to connect dots from different parts of a huge document. That is a massive leap. But wait, there's more. It's not just about being more accurate. This whole approach lets you tackle documents with over 1 million tokens. It gives the model a persistent memory that can last across different conversations. It saves you a ton of money on API calls, like 40 to 60% less, because the calls are smaller and more targeted. And it's built to be enterprise-ready, with real security baked in from the start. Okay, theory is great, but how do we actually build this thing? That brings us to step one. And believe it or not, the first step isn't writing code. It's creating a super solid project blueprint, your software design specification. Now, a good blueprint isn't just one messy document. It's a whole set of coordinated files. You've got your high-level overview, right? That's overview.md. Then you've got agents.md, which lays out all the coding rules and best practices. And then you get into the nitty-gritty with back-end and front-end specs for your APIs and your user interface. This way, everybody's on the same page, building from the same plan.
The blueprint also locks in your tech stack. For the backend, we're talking about a really modern, fast setup. You've got Python and Fast API, which are built for speed, PostgreSQL with the PG Vector extension for some seriously powerful search capabilities, and Redis for caching. And just as important, you pair all that with a real-deal security stack, using stuff like OAuth and TLS to keep everything locked down.
All right, on to step two. Let's zoom in a bit and look at the system architecture. How do all these different pieces of technology actually fit together?
So the whole system really boils down to 5 core components that have to work in harmony. You've got the main server, built with Fast API, that handles all the incoming requests. That server talks to the RLM core engine, that's where all the recursive magic happens.
Your memory, the long-term storage, is handled by PostgreSQL. Then you've got a React front-end for users to interact with. And finally, an observability stack, Prometheus and Grafana, to keep an eye on everything.
Okay, now this is important. The absolute heart of this whole thing, the engine room, if you will, is the REPL environment. REPL stands for Read Eval Print Loop. And you can just think of it as a safe, sandbox little playground where the LLM can write and run code. It's where the model can think out loud, test ideas, and crucially trigger those recursive calls to itself.
And these two images, they show this process in action beautifully. On the left, you can see the model writing some simple code just to inspect the data, pretty much exactly what a human developer would do first. And then, on the right, it decides on a strategy. It actually writes a function to process the data in batches by calling itself. It's literally reasoning its way through the problem using code. It's incredible to watch.
Okay, so we've got the theory down, we've got the architecture mapped out, so let's get to the final section. How do you actually start building? Let's talk about kicking off development.
The blueprint gives you a really clear roadmap. Step 1, you just set up your local development environment. Step 2, and this is key, you really dig in and review all that architecture documentation we just talked about. Then you can start the fun part, building the back end and the front end, all while you're already thinking ahead and planning for deployment.
You can map out the first chunk of work into a pretty logical 4-week sprint. Week 1 is all about laying the foundation. Get the fast API server up, define the database schema, and build a basic version of that RLM engine. In Week 2, you focus on the memory tools, the APIs for searching, saving, and deleting memories. Week 3, you pivot to the front end, get the React project going, and then Week 4, you bring it all together, connect the two halves, and start that super important end-to-end test. At the end of the day, this whole RLM architecture, it's more than just a cool technical trick. It's a fundamentally new capability. This is what unlocks the possibility of building AI agents that can actually understand an entire code base or perform deep research across hundreds of papers, or just have a conversation that stays coherent for days, not minutes. The blueprint is right here. So the real question is, what are you going to build with it?